What's up, everybody? Hope we're doing well here. And so today we are focusing on a couple of vocab words that we weren't able to address in the last lesson that I did on 10.2.1, which is about a week ago. And so I wanted to make sure that they were addressed today because it was a part of our lesson that we went over in 10.2.2. So I want to make sure that these vocab words are addressed. So I'm going to go through 10-62 and then part of 10-63, and that hopefully should shed some light on these vocab words. And so obviously, if you look here, we're looking at parts C and D, and then later on in 10-63 in part C about association. And so we'll start off with 62. So it says, what is the probability of a student living on campus at ETU? So to fill out a two-way table, all we need to do is add the rows together and then add the columns together, and that should get our total amount of students in at ETU. So we have 200 students that live off campus and 40 students that live on campus. So in total, we have 240 students. Just to make sure we're adding everything else, we have 36 here and then 204 here. So everything does add up. So now if it's asking what is the probability of a student living on campus at ETU, well, there's a total of 40 students, as we see here. So the probability would just literally be 40 over 240, which is the same thing as 1 over 6 if you were to reduce the fraction. Now, for part B, then copy the table and shade the cells with engineering majors. So we have these guys and this one right here. So what is the conditional probability of a student living on campus given that you know a student is an engineering major? So this is asking probability of on campus given engineering. So because we have a given question here, it narrows down our sample space to focus on the engineering majors only. So there are a total of 36 engineering majors. Of those 36, 6 live on campus. So out of the 36 students that are engineering majors, 6 live on campus, and if you reduce that fraction, it is also 1 over 6. So here's where the vocab words start to begin. Part C, two events A and B are independent if knowing that B occurred does not change the probability of event A occurring. That is, if two events A and B are independent, they are independent if the probability of A given B is equal to the probability of A. So this one, for part A, this was asking what is the probability of a student living on campus. That's the probability of A, living on campus. Over here, this is the probability of on campus given engineering, which is the event B. So if these two probabilities are equal, then they are independent. And as we see here, 1 over 6, 1 over 6. So yes, they are independent, because 1 over 6 is equal to 1 over 6. Now, of course, when we're looking at that, I mean, it makes sense. You don't have to live on campus to be an engineering major. You don't have to live off campus to be an engineering major. So naturally, those are independent probabilities. So on the flip side, if those two probabilities are not equal, that means they are dependent, meaning one of those events depends on the other. One of those events would have to depend on the other if these probabilities were not equal. Okay? So that's what independent is. Probability of A given B is equal to the probability of A. And they're not variables. They're meant to just explain, like, the first event that I tell you is event A. The second event that I tell you is event B. So because part A, I'm talking about living on campus, that's event A. And for part B, a student living on campus, that's A. For a student that is an engineering major, that's the second thing. So that's B. Okay? Now, the last part, it says two events are mutually exclusive or disjoint if they cannot both occur at the same time. That is, two events are mutually exclusive if the probability of A and B is equal to 0. So what does that look like in the table? Well, if we're talking about A and B, so living on campus is A, engineering is B. So on the table, living on campus, A, and then engineering majors are B. So right here is our number that we're focusing on. So the probability of that happening where they live on campus and they are engineering majors is 6 out of 240. If you reduce that as a fraction, you get 1 over 40. Now, I don't know about you guys, but I'm looking at this and I see that 1 over 40 does not equal 0. So they are not mutually exclusive. Okay. So that means they both can occur at the same time. You can live on campus and be an engineer. That's basically what it's saying. Rather than, if they were mutually exclusive, then they would not be able to occur at the same time. That means like engineering majors are not allowed to live on campus, which is absurd in a college perspective. So that's what it is. In terms of like a situation, mutually exclusive would mean that like in this campus, you can only live on campus if you're not an engineering major. So a biology major can live there, a chemistry major can live there, a history major can live there. Heck, even a food science major can live on campus. But if it was mutually exclusive, that means engineering majors cannot live on campus. That sucks. But essentially that's what the vocab is. Okay. So the probability of A and B is equal to 0. That's talking about mutually exclusive. All right. The last part here is talking about association, meaning are two events associated to each other. So with association, it's basically like, are they related to each other in a sense, or are they not related to each other? And so if they are associated with each other, that means they are not independent. So for association, this cannot be true. So here's what I'm going to write here in text. If two events are independent, then they are not associated. Two events are dependent or not independent, then they are associated. Because, I mean, it makes sense, right? If one depends on the other, then they have to make sense. They're together. They go hand in hand. So if they are not independent or dependent, then they are associated. But if they are independent from each other, that means they literally have nothing to do with each other. So then, of course, they're not going to be associated with each other. So if we were trying to figure out whether two events are independent or not, so it's probability of female, that's the event A. Probability of wearing jeans is event B. So remember from the previous question, they are independent if probability of A given B is equal to the probability of A. So I need to fill out the rest of this table. We have 7 plus 7, which is 14. 5 plus 13 is 18. So in total, we have 32 students in this class. And then people that are wearing jeans is 12. People that don't wear jeans is 20. So I need to figure out, does the probability of A given B equal probability of A? So to start, probability of A is the easiest because out of the 32 total students, who are female? Because that's what the first event is. So I have a total of 18 female students in this class. So here's how it started off my probability. For probability of A, that would be 18 over 32. For the other side, it's A given B. So probability that you are a female given that you wear jeans. So there are a total of 12 students that wear jeans. Of those 12 students, 5 are female. So my fraction would be 5 over 12. So if these two probabilities equal each other, that means they are independent. If they are not equal to each other, that means they're not independent and they are associated. So let's take a look. I'm going to plug this into a calculator here. 5 over 12 is 0.42 if we were to just stop there. So this is, I'm going to bring it down here. 0.42 is equal to 18 over 32 which is 0.5625. So just from plugging it into a calculator, these are not equal, which means they are dependent, and which means they are associated. So are the events female and wearing jeans associated? Yes, they are associated, and they are not independent. So they are dependent. Okay, so please remember that relationship between. If you just think about it too, like independent, you're on your own. So of course you're not associated with someone. But if you depend on someone, like how as high school students, you live under your family or who's taking care of you. So you depend on that person because they're the ones that feed you. They're the ones that, give you money for stuff. They're the ones that buy your cell phone, unless you bought it yourself, which I know a lot of people do these days. So they are dependent. So of course you're associated with whoever's taking care of you. So that's just a nice little personal example about it. So I'm hoping this helps. Again, let me know if you guys have any questions on the probability aspect. But please, please, please remember these vocab terms. All right. Have a great day, and we will see you tomorrow. Bye-bye.